Good morning to all of you. We'll continue where we left in the last class. I think in the last class I have given a problem like this. Rth term of progression Tr is equal to R into R plus 1 into R plus 2 into R plus 3. I want you to find out sum of n terms of the series. This is the problem I have given in the last class. We'll continue with this problem. You are supposed to write first Tr plus 1. Tr plus 1 is R plus 1 into R plus 2 into R plus 3 into R plus 4. So you have to link Tr and Tr plus 1. You have to connect like this. So here R is missing. Here R plus 4 is missing. So R plus 4 into Tr is equal to R into Tr plus 1 you will get. Right. So R plus 4 into Tr is R into Tr plus 1. So here R plus 1. So 1 more than this must be available here. So you do one thing, you add on both sides 5Tr. So 5Tr is equal to 5Tr plus 1, right, is equal to R plus 5 into Tr plus 1 minus R plus 4 into Tr. I will put like this. Now you range your R values. R is equal to 1. 5T2 is equal to 6T2 minus 5T1. R is equal to 2. 5T3 is equal to 7T3 minus 5T. You go on writing like this. Finally, R is equal to n. R is equal to n minus 1 otherwise. Then we will get 5Tn is equal to, if you put n minus 1, you will get n plus 4Tn minus n plus 3 Tn minus 1. You will get like this. Now you add all these things. Then, so this is 62. R is equal to 2. So the cancellations will take place like this. This will also cancel. And if you add all these things, 5 into T2 plus T3 up to Tn is equal to n plus 4 Tn minus 5T. Right? You will get like this. You bring this 5T1 to this side. So if you bring like this, you will get 5 into T1 plus T2 plus T3 up to Tn is equal to n plus 4 into Tn. T1 plus T2 plus T3 up to Tn is Sn. So 5 Sn is equal to n plus 4 into Tn. So Tr you know, therefore you can write Tn. Tn will be n into n plus 1 into n plus 2 into n plus 3. Hence Sn is equal to 1 by 5 into n into n plus 1, n plus 2, n plus 3 into n plus 4. So Sn can be estimated like this. Yes, right. So this is one of the important models you have to do like this. So the next question is, A, B, C are positive integers. A, B, C are positive integers such that B by A is integer. A, B, C are positive integers, B by A is integer. A, B, C are in GP. A, B, C are in GP. AM of arithmetic mean of A, B, C is B plus 2. AM of A, B, C is B plus 2. Then the value of A square plus A minus 14 by A plus 1. A, B, C are positive integers, B by A is integer, A, B, C are in geometric progression, and arithmetic mean of A, B, C is B plus 2. Then what is the value of A square plus A minus 14 by A plus 1? This is the question. So A, B, C are positive, B by A is integer, A, B, C are in GP. So arithmetic mean of A plus B plus C is B by. Now we will proceed like this. I will consider A, B, C are in GP means, let us say AR square. So your B will be equivalent to AR, C will be equivalent to AR square. What is B by A? B by A will be equivalent to R. So R is integer. And one more point is A plus AR plus AR square is equal to B plus by 3 is equal to how much he says B plus 2 means AR plus 2. Right? You will get like this. AR plus 2. So when you simplify this, you are going to get like this. AR square minus 2AR. Bring AR, 3AR to this side. 2AR plus A minus 6 is equal to 0. This is what you are going to get. Yes, understood? So from this, R square minus 2R plus 1 is equal to 6 by A. Right. R square minus 2R plus 1 is equal to 6 by A, you got it. Which is as good as R minus 1 whole square is equal to 6 by A. Right? Listen. your R is integer. R is integer because B by A is integer. See, when R is integer, R minus 1 whole square must be integer, and this should be what? A perfect square. Then only you will get R what? Integer. So what are possible values of A? You can have A cannot be 1 because A is a positive integer. If A is 1, 6 you will get. Then R minus 1 is root 6. Not possible. R is 2. 3 cannot be perfect square. R is next what? 6. I mean A is equal to 6. When A is equal to 6, R minus 1 whole square is 1. That is possible. Right? So, this 6 by A must be a perfect square. Like that, you have to guess the value of A. So, the only possibility is A is equal to 6. If you once know A is equal to 6, I think calculation of that A square something, I hope you can substitute and do it. Yes, I think for it's a very simple idea problem. Yes, I hope you are following this, right? So the problem is quite simple. A, B, C are positive integers, B by A integer, A and they are in what? GP. Arithmetic mean of A, B, C is B plus 2. I am assuming like this, B by A means R is an integer. Arithmetic mean of A, B, C like this. Then straight away all these equations will follow. Here, your intelligence lies in putting this equation like this. This is the crucial step. This has to click. You should not try to solve it as a quadratic and make a mess of it. So here, a sort of guesswork is necessary from your side. And this is one of the questions which already came in the examination once, and the advanced paper of course. Yes, so A value, I hope you can substitute and get the final results. See, when I am doing some good advanced problems, I am going to explain you the crucial steps where the idea should click. If once the idea clicks, the remaining part of the problem, I hope you can easily do it. I need not waste my time on that, right? Hello. Yes. Our next problem is the following. The next question is A1, A2, A3, etc. A100, A1, A2, A3, etc. A100 are in AP. A1, A2, A3, etc. A100 are in AP with A1 is equal to 3. A1 is equal to 3. SP is equal to sigma I is equal to 1 to P AI, where 1 less than or equal to P less than or equal to 100. So SP is equal to sum of first P terms. For any integer n, 1 less than or equal to n less than or equal to 20, m is equal to 5n. m is equal to 5n. m is equal to 5n. Sm by Sn does not depend on n, does not depend on n. Then find 8. What is the value of 8? See, the question is very much clear. It is like this. A1, A2, A3, etc. A100 are in AB. A1 is 3. Sum of first p terms is denoted by the symbol sigma is equal to 1 to pi, where p value lies between 1 and 100. See, for any integer n lying between 1 and 20, m is equal to 5n. He says that Sm by Sn does not depend upon n. What is the value of 8? This is the question. So, we think like this. It's a direct question. I did already a problem like this once. You have to think in this way. M is what? 5n. Therefore, S5n by Sn must be independent of n. S5n is what? 5n by 2 into A is 3, first term is 3, A plus 5n minus 1 into D by n by 2 into 6 plus n minus 1 into D. Right? So, n by 2 will go. So, you are going to get 5 into 6 minus D plus 5nd whole divided by 6 minus D plus nd LH. Yes, I think you are following this. See, this should be independent of n. Means you have to closely inspect the problem. If you inspect the problem, if I put 6 minus D is equal to 0, you will get what? 25 nd by nd, which is how much? 25, which is what? Independent of n. So, by inspection, it is quite clear for you that D must be equivalent to 6. D must be equivalent to 6. When once D is 6, you know common difference of that AB. You know first term happens to be 3, common difference is 6. Therefore, A2 will be what? A2 will be A1 plus D, 3 plus 6, which is 9. Which is a very, very simple question. Right? Understood? Your intelligence lies in identifying this fact. This should be independent of n means what must be the relation. So if you simply observe that D is equal to 6, the problem is over. The next question is, the roots of the equation 10x cube minus nx square minus 54x minus 27 is equal to 0 are in HB. The roots of this equation are in harmonic progression. Then find the value of n. What must be the value of n? The roots are in HP. What must be the value of n? That is our next question. See, by this time you should remember that suppose f of x is equal to 0. Roots are, let us say, alpha 1, alpha 2, alpha 3, alpha n. Then for f of 1 by x is equal to 0, roots are what? 1 by alpha 1, 1 by alpha 2, 1 by alpha 3, 1 by alpha n. F of x is equal to 0 is a polynomial equation. The roots of that equation are alpha 1, alpha 2, alpha 3, alpha n, let us say. I want to form you an equation whose roots are reciprocals to the of roots of the equation f of x is equal to 0. Means you simply replace x with what? 1 by x. Now, in this problem, let us say alpha, beta, gamma are roots. Then you consider an equation whose roots are 1 by alpha, 1 by beta, 1 by gamma. Means what you have to do? Replace x with 1 by x. Then you are going to get 10 by x cube minus n by x square minus 54 by x minus 27 is equal to 0. For this, roots are 1 by alpha, 1 by beta, 1 by gamma. Understood? Now you can take LCM. You will get 27x cube plus 54x square plus nx minus 10 is equal to 0. So roots are what? 1 by alpha, 1 by beta, 1 by gamma. Listen, alpha, beta, gamma are in what? HP. So 1 by alpha, 1 by beta, 1 by gamma must be in what? AP. That means what? This equation will have its roots in arithmetic progression. So when you replace x with 1 by x, you will get one resultant equation. That equation will have its roots in arithmetic progression. See, whenever three numbers are in AP, we assume them as what? A minus D, A plus D like this. Correct? So you can assume 1 by alpha as A minus D, 1 by beta as A, 1 by gamma as A plus D. What is sum of roots? Sum of roots is equal to, this is 3a. Sum of the roots is minus of x square coefficient by x cube coefficient. This point all of you know. So you are going to get minus 54 by 27, which is minus 2. So 3a is equal to minus 2 you get. A value will be equivalent to minus 2 by 3. A value will be equivalent to minus 2 by 3. Remember, A is a root of this equation. A happens to be root of the equation, is it not? A minus D, A plus D are roots. A value, you got it. Since A is a root of this equation, this has to satisfy this equation. So when you substitute A is equal to minus 2 by 3 in this, what will get? 27 into minus 8 by 27 plus 54 into 4 by 9 minus 2n by 3 minus 10 is equal to 0. You will get like this. 27 will go. 9 sixes, right? Is it possible to get n value? So you can easily calculate your n value. So whenever in the problem roots are in HP means, you replace in that equation x with 1 by x. Then for the resultant equation, roots will be in AP. Like that, you can complete this problem. Yes, n value, I think directly you can get it. So roots are in equivalence. This is what you are supposed to do it. Yes, understood? So the next question is, hold on this. A1, A2, A3, A101 are in GP, are in geometric progression. A101 is equal to 25. A101 is equal to 25. Sigma I is equal to 1 to 201 AI is equal to 625. 625. Find sigma I is equal to 1 to 201 1 by AI. I is equal to 1 to 201 1 by AI. You have to calculate this. So A1, A2, A3, A101, they are all in what? GP. Then sigma I is equal to 1 to 201 AI is given. You have to calculate 1 by AI. I will assume this GPA like this. AR square, AR to the power of 100. This is A101, etc., 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 like this. Right. Now, given what? AR to the power of 100 is equal to 25. This is A101. This is given. What about this sum of 201 terms? So, A into R to the power of 201 minus 1 by R minus 1 is equal to 625. So, those two things are given for you. A into R to the power of 201 minus 1 by R minus 1 is equal to 625. So these two are given. You are supposed to calculate like this. So actually when you closely look at this, this is nothing but what? 1 by A, 1 by AR, 1 by AR square, 1 by AR to the power of 200. Correct? This is also a geometric progression, right? So this plus this plus this means what you are going to get? 1 by A into, see I considered there ought to be greater than 1. So 1 by R will be what? Less than 1. So I will write 1 minus 1 by R to the power of 201 by 1 minus 1 by R I will write. Yes, understood? This is nothing but what? This is nothing but this is 1 by A. R to the power of 201 minus 1 by R to the power of 201 whole divided by R minus 1 by R. This is what you want. R to the power of 201 minus 1 by R to the power of 201. 1 by A as it is. R minus 1 by R like this. So when you further simplify this, what happens? r power 201 minus 1 by r minus 1. R power 201, r means we'll get what? R to the power of 200. So 1 by ar to the power of 200 will get. Yes, I think you're all following this. Don't confuse with this. So 1 by a, 1 by r, 1 by r square up to this. This is what this. You simplify. You will get like this. Right? Okay. Now, you know this. A into r power 201 minus 1 by r minus 1 this. So, you simply multiply with a. You put here a square. You put here a square. A square like this. Now the idea is, listen, this is 625. This is 1 by ar to the power of 100 whole square. A square r power 200 means what? Ar to the power of 100 whole square. Ar to the power of 100 is there here. So 625 by, this is what? 25 square. 25 square is this, which is 1. Okay, understood? Yes, I think this is a direct question. The only thing is you have to properly write the data. This data just implement and ask a question what you are supposed to calculate. You blindly write sum of 201 terms and just to see that data, try to adjust here. So this is called manipulation. See, mathematics is manipulation. Manipulation comes through practice. Practice not for practice purpose. You have to involve and practice. That's more important. When you are practicing, you have to enjoy it and involve in that. And especially your JEE always requires good practice. The next question is sigma n is equal to 0 to infinity 2n plus 3 by 3 to the power of n. Sigma n is equal to 0 to infinity 2n plus 3 by 3 power n is equal to how much? The next question is sigma n is equal to 0 to infinity 2n plus 3 by 3 to the power of n. Sigma n is equal to 0 to infinity 2n plus 3 by 3 power n is equal to how much? You try to expand this. You are going to, when you put n is equal to 0, 3 into 1 by 3 power 0. When you put n is equal to 1, 5 into 1 by 3. You put n is equal to 2, 7 into 1 by 3 square. Up to infinity. Up to infinity. It is a arithmetical geometric progression. 3, 5, 7, they are all in what AP? 1 by 3, 1 by 3 square, they are all in what GP? See, in the arithmetical geometric progression, sum to infinity formula I told you to remember, which is A plus B into R, A plus 2D into R square, up to infinity, is equal to A by 1 minus R dr by 1 minus r whole square provided when mod r less than 1. When mod r is less than 1, we can apply that. Is it not like that? 3 into 1. A plus d into 1 by 3. A plus 2d into 1 by 3 whole square. So, your A is equal to 3. R is equal to 1 by 3. Therefore, and what about D? D is equal to 2. So, directly you can apply this. Then you are going to get 3 by 1 minus 1 by 3. 2 into 1 by 3 by 1 minus 1 by 3 whole square. Simplify this result. That's it. Yes, I think you are following. So this is a direct formula. See, when you are applying this formula, you should see whether this problem is according to this result or not. Sometimes it so happens you get 3 into 1 by 3 like that starts. Then you should be very careful. You have to adjust it, put it in this form and apply the formula properly. Evaluate sigma n is equal to 1 to 9,999 1 by root n plus 1 into 4th root n plus 4th root n plus 1. 4th root n plus 4th root n plus 1. Evaluate this. Right. We will first rationalize this expression. See, n plus 1 whole power 1 by 4 plus n power 1 by 4 you consider. You multiply with the conjugate of this. N plus 1 whole power 1 by 4 minus n power 1 by 4 and divide with that. N plus 1 whole power 1 by 4 like this. Then you are going to get, see, a plus b into a minus b form, a square means what? N plus 1 whole power half whole square minus n power half by n plus 1 whole power 1 by 4 minus n power 1 by 4 you are going to get. Right? So you try to rationalize this. So you got like this. So shall I write directly now from here onwards? N plus 1 whole power 1 by 4 minus n power 1 by 4 I wrote. So when I multiply, I got what? I will get what? I will get n plus 1 whole power 1 by 2 minus n power 1 by 2. Watch. When I multiply and divide, this becomes what like this. Now this is once again a plus b into a minus b form. So finally you will get what? N plus 1 whole power 1 by 4, n power 1 by 4, this square minus this means 1. Right. N value ranges 1 to this. When you range n values, n is 1 you put. 2 power 1 by 4 minus 1 power 1 by 4 plus 3 3 power 1 by 4 minus 2 power 1 by 4. This will come here. Plus 4 power 1 by 4 minus 3 power 1 by 4. Finally, etc. etc. 10,000 whole power 1 by 4, 999 whole power 1 by 4. This. So when you take only two terms, only this minus this will be available. When you take three terms, this minus this will be available. So what is 10,000 whole power 1 by 4? 10 minus 1. So 9. You will get 9 like this. Okay, understood? Our next question is the following. The fifth and eighth terms of eighth terms of geometric progression are factorial 7, factorial 8 respectively. Fifth and eighth terms are factorial 7, factorial 8 respectively. Sum of first n terms, Sn is equal to 2205. 2205. Find the value of n. Find the value of n. This is also a direct question. This question is a direct question. A r to the power of 4 is equal to factorial 7. A r to the power of 7 is equal to factorial 8. So when you divide one by the other, this by this will give you r cube is equal to 8, r is equal to 2. So if you know r value, right? And if you put r value here, you will get a value, right? You know a and r. Sum of n terms is what? A into r to the power of n minus 1 by r minus 1 is equal to 2205. Right? So you can substitute r value and a value, hence you can calculate n value. There is nothing much to explain in this problem. I hope easily you can do this. The next question is, a pack contains n cards. A pack contains n cards numbered from 1 to n. A pack contains n cards numbered from 1 to n. Two consecutive numbered cards. Two consecutive numbered cards. Two consecutive numbered cards are removed from the pack. Two consecutive numbered cards are removed from the pack. And the sum of the numbers on the remaining cards. Sum of the numbers on remaining cards. Sum of the numbers on remaining cards is 1224. 224. If the smaller of the numbers, on the removed cards is, let us say, k, then find the value of k minus 20. What is the value of k minus 20? This is the question. See, there are n cards numbered 1 to n. Two consecutive numbered cards are removed from the pack. Sum of the numbers of the remaining cards is 1224. Smaller of the numbers of the removed cards is k. Then what is k minus 20? This is the question. See, the numbers are what? 1, 2, 3 up to n. Right? Let us say you removed k and k plus 1. You removed k and k plus 1. See, the remaining sum is how much? 1224. 1224. See, shall I put it like this? Say, let us say k value is 1. Then k plus 1 is what? 2. Then you will get maximum sum. So this will be your 1224 will be definitely less than what? 3 plus 4 plus 5 up to n. Correct? See, if you are removing the smallest, see, the remaining numbers is 1, 2, 2, 4. Right, okay. Say k and k plus 1 will be in between. So you are removing from this sum the smallest numbers. 1 and 2 means, so this is bigger. If you remove, let us say, n minus 1 and n, then 1, 2, 2, 4 will be what? More than that. 1 plus 2 plus 3 up to n minus 2. See, what I mean to say is like this. Let us say you are having 1, 2, 3, 4, 5, 6 is there. Suppose if you calculate this sum, this is how much for you? 5 and 6 you removed. Means what? 4 into 3 by 2 means 6 you will get. If you calculate this sum, you are going to get how much? 7 plus 5, 12. 12 plus 6 is what? 18. In between, if you remove any two numbers, let us say 3 and 4 you removed. What will you get? 1 plus 2, 3, 8, 16, 14. So that should lie between these two. I think you followed this step. Say 1, 2, 2, 4 is for in between any two numbers. If I remove these two, this is more. The maximum is this, minimum is what? This. So this is a crucial step. I think you are following this step. So if I remove the maximum numbers, then the sum is least. If I remove minimum numbers, the sum is what? Greatest. In between numbers, if you remove, it is what? 1, 2, 2, 4. So that 1, 2, 2, 4 should lie like that. Yes, I think you are following the problem. Now you consider this sum. This is n minus 2 into n minus 1 by 2 less than 1 to 2. This is n into n plus 1 by 2 minus 3 greater than 1 to 2. Right? You get two quadratic inequalities that you have to solve. So when you simplify this, n square minus 3n, this is 2, 4, 4, 8, 8, 4, 4, right. Bring it to this side, minus 2, 4, 4, 6 less than 0. This is n square plus n, right, minus, right, multiply with 2, 2, 4, 4, 8, 1, 2, 4, 4, 8, and 3, and 1, 2, 2, 7 into 2. 2, 4, 5, 4, greater than 0. You write like this. So quadratic inequality less than 0 means n value should lie between the roots. So if you roughly calculate roots, what you are going to get? 3 plus or minus square root of 9 plus b square minus 4ac. 9784 by 2. So 3 plus square root of, this is how much you will get, 9991. Sorry. 9793 by 2 plus or minus. What is 9793 square root approximately? Approximately, actually 99, approximately I am talking. Approximately 99 into 99, how much will get? 9 9s are 1, 89, 8, 91, 1, 0. This is 8. Nine eight 0 1. So approximately I will take this as what? 99. So 3 minus 99 by 2 means how much will get? 96 by 2 and minus 48. 3 plus 99 by 2 and 3 plus 99 by 2 and 51. Approximately, not exactly, approximately. Then what about this? What about roots? Minus 1 plus or minus square root of 1 plus 9816 by 2. So that is also 99 I can consider. Then I am going to get n less than the smaller, because greater than is there. Minus 1 minus 99 and minus 50. Or n greater than how much? Minus 1 plus 99 and 98, 49. So it has to satisfy this, it has to satisfy this. So therefore, if you consider intersection of these two, when you consider intersection of these two, you will get n value to lie between 49 and 51. Yes, understood? So here, you will not get exact root, you need not write, because The idea is n must be what? Integer. So I am going for closest approximation. This is square root of this is approximately 99. That is also approximately 99. Then possible integer values we are going to get like this. N cannot be negative anyhow because n should be always positive. So intersection of these two when you write n greater than 49, n less than 51 you will get. But n is what? Integer. So n must be equivalent to 50. N must be equivalent to 50. Yes, understood? So n is equal to 50, you got it. Okay. After getting n is equal to 50, the removed numbers are what? K comma k plus 1. So n into n plus 1 by 2 minus 2k plus 1 is equal to 1224. Yes. Understood? N into n plus 1 by 2 minus 2k plus 1 is equal to 1224. So 50 into 51 by 2. So 25 into 51 minus 2k plus 1 is equal to this. So 25 ones and 25 to 25 fives, 125, 125 to 127 minus 1224 is equal to this. So 1, 5 is equal to 2k. So 2k is equal to 50. So k is equal to 25. Right? This is how you have to think. See, the crucial step here is the following. See, 1, 2, 3 up to n numbers are there. You removed in between k and k plus 1. Then the sum happens to be 1, 2, 2, 4. You keep 1, 2, 2, 4 like that. This is definitely greater than the sum what you are going to get when you remove the biggest numbers. That is what? N minus 1, n. So your 1, 2, 2, 4 definitely greater than 1 plus 2 plus 3 up to n minus 2. This is definitely less than the sum what you get if you remove least numbers. That is what? 1 and 2. So 1, 2, 2, 4 definitely less than 3 plus 4 up to n. So that is the crucial step. Once you got that idea, the remaining blindly follows. Just you will get a quadratic inequality here. You will get like this. You need not solve fully. You need not get square roots and all those things. Because n being integer, you can write approximately like this. Approximately what you got earlier, n value minus 48 to 51. Similarly, the other inequality if you solve, you will get n less than minus 50 or n greater than 49. N cannot be negative, so you have to consider what? The intersection for this and for this, which happens to be this. Then immediately here n, the only integer which lies between 49 and 51 is what? 50. So had it been, let us say you got 48 and 51, then you have to take some more inspection. I mean n is equal to 48 or 49, one case, n is equal to 50, one case, like that you have to consider various cases. But fortunately here you got only one integer to lie between what? 49 and 51. So therefore n value 50 you got. Next point is n into n plus 1 by 2 total sum minus removed numbers sum is equal to 1, 2, 2, 4. So substitute n value, get k value. This is how you have to tackle this problem. I hope you understood this problem. Okay? Right.